Hello and welcome. This video is to fulfill the requirements of distributed system module assignment 2. And basically this is about a fire alarm monitoring system. And this is my team. I am DSR CV Pereira and I am accompanied with Pabasra DVH and NA Yapa. And now let me briefly introduce you all the system architecture. Basically we have REST services implemented to add new sensors, edit sensors, and to view all those information indicating the carbon dioxide and smoke level, and also the room number and floor number and other relevant information. How the things will work is we have implemented desktop client which will communicate with the REST API via a RMI server. So in the desktop client, there are two logins. First one is admin login and the second one is guest login. So the basic difference between those two logins is admins are privileged to both add and update the sensor details, but guest users can only view the sensor information. So all those added and updated information will be stored in a remote database, and we have used MySQL for the handle that, and our database is phpMyAdmin. And by other hand, we have implemented a web client as well, where the users can view all the sensor information indicating the carbon dioxide level and smoke level. So if in cases fire sensor detects a carbon dioxide or smoke level more than 5, that will be indicated as a danger, and they will be marked in red both in both web client and desktop client. And the other thing which will happen is the RMI server will send the email to the admin, including the relevant information about the incident which is happening in the relevant floor and the room. In this slide, I have listed the technologies that we have used in the implementation. To do the REST services, we have used Springboot and Java. So to do the RMI server, we have used Java as well. And to do the dummy sense application and the view sense application, we have used React and we have used Bootstrap for the styling. And to handle the DB part, it's MySQL. And now let's take a quick demonstration about the system that we have developed. Firstly, I'll run the REST services like this. And to do that, Apache and MySQL should be running in the XAMPP control panel just like this. Okay, the save has started, and next thing I'll be doing is running the RMI server. Running it like this. It says service running, and I'm good to go. So this is the basic interface that we have in the desktop client. So for the demonstration, I'll be using the admin login. So to access the system, I'll be using my existing credentials, admin as my username, and enter my password here, and I log in. So once you logged in, it should display the current details which are there in the database, and I'll be adding a new sensor here. I'll give the sensor ID as 4 and the floor number as 2 maybe, and the room number 98. So I'll click on the button add, and it should display in the grid. As you can see, it was successfully done, and now we can check the edit sensor functionality here. So right here I can change the room number to 88 maybe for this test case, and I click on the button edit. It says edited successfully. You can see the edited information is displayed here. So initially the smoke level and CO2 level is 0 here, and they can be updated using the dummy sensors. And basically this is it for the desktop application, and we can move to the web client now. So here's our web client, and I'm running it using the npm start. It's running here, the port number 3000. As you can see, all the current sensor information is displaying here, and I can edit those information using my dummy sensors, and I have already run that application previously for the convenience. And if I really, there are basically two types of dummy sensors. These first two highlighted in white are hard coded for the first and second sensor, and by using this third sensor, which is highlighted in dark blue, we can use it for update any of the sensors by providing the relevant information for these fields, ID, sense ID, CO2, and the smoke level likewise. So if I really need to update the most recent sensor that we have added a few moments back, I'll add the PID as 29 and the sense ID as 4. So in order to make it to the danger level, I'll make the CO2 level as 6 and the smoke level as 8. So once I update these details, this grid should be updated within 40 seconds, as I have given the refresh period for 40 seconds. So now I'll be updating the details. It's a successfully updated, and within 40 seconds it should be updated this grid. So we can wait and see. As you can see, the sensor information is updated here saying danger. So the other thing which will should happen parallelly is sending the email to the admin. So we can check it here by refreshing the Gmail. As you can see, we have received the uh, alert email with the relevant information, sense ID 4 and room number 88 and the floor number 2. We can check if the information is correct comparing to the sensor information provided in the room number is 88 and floor number is 2, and yeah, the information given is correct. So, and also in the desktop client, the information there is also updated. They are also highlighted in red. So that is basically it for the functionality of our developed system. Thank you so much for watching.